Hey everyone, and welcome to our 1.4 lesson in the Big Ideas textbook on solving linear systems, it says, but specifically these are 3x3 systems that we're going to solve here. You should have already seen the video for the 2x2 systems and now be ready to look at a 3x3 system, which would just mean there's 3 equations and 3 variables to solve for. So we are going to start by just looking at a little cartoon first. Here's a Far Side cartoon. Some guys, it looks like they broke out of jail, tunneling their way. We're almost free, everyone. I just felt the first drop of rain. Apparently they're under the ocean. Okay, so in your vocabulary, you can write this down for the linear equation in 3 variables. You can just kind of write this equation down here, ax plus by plus cz equals d, where the a, b, c's are non-zero numbers. So that means just, the a, the b, the c will all be numbers. D would be a number. The variables would be x, y, and z. That's what it says here. X, y, and z is the variables in an equation. The system of 3 linear equations, you can see now it would be like this. You don't need to write this down because you have examples for this over there in our extra practice, which we're going to get to. But I do want you to write this down, that a solution of such a system is an ordered triple. And that would be this right here. You can write that down as an ordered triple is just x, y, z. And so instead of like x and y here, like here, this would be our ordered pair that we've done before. If we stopped it right there, x, y. Well, now we include the z for an ordered triple. So now we just put x, y, then comma, z. So it's an ordered triple. And really kind of, it says visualizing the solutions to this, what these would look like would be something more like a plane, like a piece of paper as a plane, a flat surface. So it's not just a straight line like the 2x2 systems where the solution there was a point of intersection of 2 lines, or it could be no solution if they were parallel lines, or it could be infinitely many if it was the same line. But you can see here's the 3 different ones we have. We have exactly one solution if it's one spot right there where these 3, like let's say pieces of paper here, are all going to intersect. So the planes intersect in a single point, which that would be the solution to the system. So that's what we're talking about if you can visualize what we're actually trying to find. And then infinitely many solutions would be when those pieces of paper are all intersecting and the intersection is an infinite line like this. Now remember, these pieces of paper would be infinite pieces of paper that would continue to stretch and go every direction to infinity. So that means this line would also stretch up and down towards infinity as well. That's why it's infinitely many solutions. The no solution one, there's 3 options you could get for no solution. So there's the parallel one that we actually saw with the lines, parallel planes. They're not touching each other. So that means they're never going to intersect. Here's another one where these 2 are parallel. This one's going through it some way. So you're not going to get all 3 of them touching at the same place. So basically there are no points in common with all the 3 planes. Here's another situation too. You can see not all 3 are touching at the same time or in the same place. So there's not much to do with this, just other than for you to understand what it looks like to visualize it. Because I know we can visualize the 2x2 systems when they're just straight lines and we're trying to find the solution there as a point of intersection on a coordinate plane. But this is a little bit different. But the main thing we're looking at is actually how to solve these systems. So that's what we're going to get to. So solving these systems is like a little process here. It shows you the steps of doing them. You can go ahead and read through the steps. I'm going to show you these steps here, maybe in a little different way possibly than what it actually says here, but these are written out for you here, which is a good way to remind yourself of doing this, and you have that in your notes. But let's actually get to the extra practice and try a couple. Okay, so here we are, 1 through 3. Solve the system using the elimination method. First of all, we're going to skip number 2. Just for one, it's a lot of work here, and there's just not a lot of space on your notes to do all 3 of these there. So you can go ahead and just maybe cross out number 2 as fine, and draw maybe a line down the middle so we can do number 1 on the left side and 3 will be on this side. So we're not doing 2. The other thing is, it says the elimination method. We should be familiar with that from the 2x2 systems. In this case, though, I want to call that triple elimination. That's what you want to kind of remember, triple elimination. And so what that means is we're going to have 3 eliminations before we actually can find just even one of the variables. It does take some time and some patience here. So buckle your seatbelt and get in for a long ride. Alright, so first of all, what I'd like to do is number these equations. That way we can just have a reference point. So equation 1, 2, and 3. So you can go ahead and number those so we know which ones we're talking about. And we need to put 2 of these together. Just choose 2 of these to put together. Now there is a little bit of a strategy in which you want to choose. You want to look for a variable that you can get rid of pretty easily by combining them together. So we're going to be doing combining these equations together to eliminate a variable. And if we look at some of these, I'm going to choose to put together 1 and 3 first. So equation 1 and equation 3, if you look at that, we have an x, 4x, 2y, 3y, negative 3z, positive 2, or positive 1z. So the one that is the opposite sign is the z's there. That might be the best one to get rid of in this case. And so what we would want to do then, if that's the case, then we need to multiply the equation at the bottom there, that third equation, by 3. And the reason why is so we have, as we multiply this by 3, this z here will become a 3z, which will be opposite of our negative 3z. So we'll multiply every term in this one by 3. So first, we're going to just rewrite this equation, equation 1. I'm going to put it down here. So let's rewrite equation 1. The x, the plus 2y minus 3z equals 11. That's equation 1. And now we need to write down below this kind of a new equation 3 after we've multiplied by 3. So as we do this, 3 times 4x is going to be 12x. 3y times 3 is 9y. Z times 3 is that positive 3z. And there we're able to cross those ones out, as you can see is what I did. And then on the other side, the equal sign, 3 times 16, that's going to give us equals 48. So now at this point, we're going to combine all of these together, and these ones canceled out, so we'll just have an equation with the x and the y still left in there. So x and 12x makes 13x, 2y, 9y makes 11y, and then it equals over here, the 11 plus the 48. We're adding these together, so we're making sure you add them terms, add the like terms together to get a new equation. So now this would be our new equation here. We're going to get 2 new equations with 2 variables in them. So we're going to do this whole process here just one more time. And we're going to pick 2 equations up here, but it can't be obviously the same 2 equations. We will need to use one of these equations twice. So what I'm going to do is use equation 2 and 3 on this next one. So I'm going to pick equation 2 and equation 3. And so on this time, we're going to multiply equation 3 by 2. The reason why is, again, we have to cancel out the same variable. So I can't, cancel z on this one and then cancel the x on the other one. That won't work. That doesn't help us. We need to cancel out the same variable. So I'm going to try to see what I can do here to do that. So I have a negative 2z on equation 2. If I multiply this by 2, then I'll get a positive 2z on equation 3. So that's what we want to do. We want to first write down, just copy down equation 2. That we're not doing anything to, we're not touching it, it's just still the 2x plus y minus 2z equals 9. This one we want to rewrite this one as we multiply this equation 3 by 2 this time. We're going to write it down below this equation. So that's going to give us 2 times 4x, 8x, 2 times 3y, 6y there, 2 times the z, so there's the z terms able to cancel out again. So notice I canceled z's out on both of these. You have to make sure it's using the same variable to cancel out. And then we have the 2 times 16 is 32 on the other side. And then we'll go ahead and combine the like terms. The z's are gone, so they've been canceled out. So the 2x, 8x is 10x, y and 6y is 7y, and it equals 41 on the other side. So now we have 2 new equations here. And what we need to do now is we're going to solve the system of the 2 equations just like we did with the 2x2 systems in the previous lesson, our review lesson. So we need to look for a variable, one of these 2 now, x or y, to eliminate, to cancel out. And we should figure out which one would be the easiest one to eliminate. And it really doesn't matter on this. You could eliminate x or eliminate y. I think I chose to eliminate y this time. Since we have 11 and 7, I typically go with the smaller numbers. when I'm trying to cancel something out. So in order to cancel out the y's, I need to make them the same number. So 7 times 11 will be 77. So I can do that to both of these. Multiply this equation by a 7, multiply this one by an 11. So we'll start with the first equation here. Multiply it by 7. So 7 times this 13x plus 11y equals 59. That's going to give me this equation now. 91x plus 77y equals 413. That's just multiplying each of those three terms by 7. Now we'll multiply this one. In order to get the 77, I got to multiply this one by 11. However, I do want them to be opposite signs, so this one I'm going to multiply by a negative 11. That way I have an opposite sign from the positive 77. I'll get a negative 77. So our equation on that one is negative 110x from 11 times 10. And then negative 77, and there we can cancel those y's out now. And then negative 11 times 41 is negative 451. And we'll go ahead and combine our like terms here with the x's and the numbers on the other side of the equal sign. And notice what we get is we get an equation that we can now solve, and we can now find x. And notice the triple elimination that we just did. 3 eliminations, 1, 2, 3. 3 eliminations before we could actually get down to just solving for one variable. And then even at that point, we're not finished. So we're going to divide by negative 19 just to solve this now. So divide that. Negative 38 divided by negative 19 is 2. So we know now one variable out of the 3. X is 2. We now need to go backwards and start plugging 2 into one of these equations here, probably one of the original ones that we found, not the ones with the bigger numbers. So you want to either go to this one with the 13x or this one with the 10x, and I typically again go with the ones with smaller numbers. So we're going to plug 2 in, and I'm going to use this equation with the smaller numbers. So 10 times 2 for x, and then it's plus 7y equals 41, and we'll be able to now solve for y, because this is now 20 right there. Plus 7y equals 41. So a quick little two-step equation. Subtract 20 from both sides. So 7y equals 21. Divide by 7. And we know now y equals 3. So now we found 2 out of the 3 variables. We still need to find z. So we find z by taking both these letters, x and y, that we found, the 2 and the 3, and plugging both of those back into one of our original equations where it has all 3 variables in them. So on this one, and again, you could choose any one of these 3. I typically, again, go with the smaller numbers. So I'm choosing the top one here, equation 1. No, I'm not. Sorry, I lied. I'm choosing equation 3. I could have chosen equation 1, but I don't know. I chose equation 3. The reason why I did that, there it is, it's because it just has a z. So that makes it a little bit easier to solve. I'm not going to have to divide by a negative 3 or a negative 2 like these two did. So this one, because it just says plus z, did make it a little bit easier perhaps. So 4 times the x, we know our x is 2, so that's 8. 3 times y, y is 3, so that's 9. Plus the z equals the 16 from the equation. And these two give us 17, so we're going to see 17 plus z equals 16. And then subtract the 17, and we found z. Z is negative 1. So now the last thing would just be to write it as that ordered triple like we learned before. Here's how we write the solution for these 3 by 3 systems. Ordered triple. X, y, then z. So 2, 3, negative 1. There's our answer. Alright, so you may want to take a little break before we get into number 3. We got a long road here with doing these triple elimination ones. Alright, so for this one, let's go ahead and number these again. And we need to pick 2 equations to figure this out. Now, which ones do we want to pick? It really doesn't matter, but I do like to look for the variable that might be the easiest to solve for. So on this one, I'm going to choose equation 1 and 2 first. And I'm looking to solve probably for, maybe eliminate the z's, or maybe even the y's perhaps. Those might be the easiest ones to eliminate for. Let's go ahead and see what I chose to do. So I'm multiplying this one by 3. And I'm going to eliminate with 2. So I am going to choose to eliminate the y on this one. I could have chosen z. I could have multiplied it by 2 and I would have eliminated the z's at that point. But I chose to do it with the y. So just to show you that it doesn't matter which variable you choose to eliminate first. But I do choose this equation here probably to use twice because it's the one that just has the 1x, the 1z, and the 1y in there. So we're going to have to choose one equation to use twice, and that will probably be this one, number 1. So 1 and 2, when I put those together, we'll have to multiply this in. So we're going to see 3 times x, 3 times y, 3 times negative z is negative 3z, and then 3 times negative 9 is 27. And now I'm going to just rewrite equation 2. I don't have to multiply this by anything because I already have a negative 3y to cancel with my positive 3y. So I just rewrite that one, and you can see I'm canceling out the 3y's there. And now we're going to go ahead and just combine the like terms. So I'm going to get 5x from the first ones. I'm going to get a negative 1z, and then it's going to equal negative 14 from subtracting these numbers here because they're different signs. So we just can combine like terms is what we're doing. And now I got to do that one more time. I'm going to use equation 1 again. I'll use it with 3 this time. So equation 1 and 3, I'm going to multiply by 5. I have to eliminate y again. So I have to choose y, so I have to make this 5y, so I have to multiply by 5. So let's go ahead and multiply this entire equation 1 by 5 this time. So 5 times x, 5 times y, 5 times negative z, and then 5 times negative 9 is negative 45. And then we're going to just copy down, go ahead and just copy down equation 3 there, just below it. You're not going to change that one at all. And as we copy that down, you could cross out the y terms because they are opposites. Positive 5y, negative 5y, and they cancel each other out. And now we're just going to combine the like terms, what's left. So we're going to get an 8x minus 11z from the z terms, and it's going to equal a negative 60 over here on the other side. So now again we have our two new equations, and this is now back down to the 2x2 system that we've learned before. So we're just going to have to figure out, do we want to cancel x or z? And I think z would be the better one because it says a negative 1z here. So let's go ahead and try to do that. To cancel out the z, all I need to do is multiply this equation here by a positive 11. That way it's opposite of negative 11. So this whole equation we're going to multiply by a negative 11, so that way it will become a positive 11. So negative 11 times 5x is negative 55x, and then we got negative 11 times negative z is our positive 11z. Negative 11 times negative 14 is positive 154. And now I'm going to take this equation with 8x minus 11z and just put it down here, just rewrite it right below here. So I'm putting that down, same equation, I don't change it at all, I just copy it down. And I'm noticing that I'm going to cancel out my z's here because they're opposite, 11z and negative 11z. They can cancel. And combine the like terms of what's left. So I'm taking 8 away from 55, it's a negative 47, and it's equal to 94 because we're going to subtract 154 minus 60. And we'll divide by our negative 47. And when we do that, we're going to end up with x is equal to negative 2. Now let's go ahead and plug this negative 2 back into one of these two equations here. This one here will probably be the easiest one, just by 5x minus z. We know our z, or our x term is 2, negative 2 I should say, so 5 times negative 2. So that'll be over here, and I'm just going to put under here. So 5 times negative 2 from this equation minus the z equals the negative 14. And now I'm just going to do negative 10 there, and then add 10 to both sides. And so it's going to give us a negative z will equal negative 4. So just change the signs of both sides, and positive z will equal positive 4. And now we take both of these two numbers and plug it back into one of our original ones, and the easiest one's going to be this equation 1. So we can just put x and z in here and then solve for the y. So that's what we'll do. Negative 2 plus y from our equation here minus the 4 from z. Remember, it's a negative z, and z is positive 4. So now it's minus 4, and it equals the negative 9 from the equation. So we'll combine the like terms. Negative 2, negative 4 makes negative 6. And then we just add 6 to both sides. So negative 9 plus 6, y is a negative 3. So now our answer is an ordered triple with x first, then the y number, then the z number. So it'll look like this: negative 2, negative 3, then positive 4. Alright, so let's move on to the next ones we'll do. Okay, I'm going to give you a chance to try some now. Number 4, let's go ahead and number them. Number the equations, 1, 2, 3, and 4. We're going to do the same thing here, not do 5. So we'll do 4 and 6 on our notes. Go ahead and mark, just draw a line down the middle so you can do 4 over here on the left side. And I'm going to have you try to make your new equations, 2 new equations. I'll show you which ones I want you to put together. So put together equation 1 and 2 and make a new equation out of that by eliminating, let's eliminate z on this one. So as you can see, they're even set up for that on equation 1 and 2. So you don't have to really multiply by anything. And then equation 2 and 3 do the same thing. So you're using equation 2 twice. So go ahead and pause the video and then make your 2 new equations and then play it from there. Okay, so hopefully you've got your 2 new equations down. You did these 2. And so our 1 and 2, if you put those together, we see the z's are going to cancel each other out. And as you combine the like terms, you get 2x, 2y, and it's going to equal an 8. For equations 2 and 3, as you combine those 2 equations together, the z's again will cancel each other out, and you'll combine and get 4x plus 4y is equal to 16. And now we want to eliminate one of these variables. We can try to eliminate x with a 4x, 2x and 4x. If I multiply this by -2, that'll become -4x as well, so I can cancel it out with the positive 4x. So we want to multiply that equation there, the smaller one, by -2. And so as we do that, -2x times x is a -4x, and that would combine with the 4x and cancel out from this equation. But notice what's happening. -2x times -2y is -4y, which will combine with the 4y and cancel that y out as well. We got rid of x's and y's. So if that's the case, we've already eliminated the z's. Now we've eliminated both x's and y's. We have no variables to solve for. So this would be one of those special occasions where you're going to either get a no solution answer or an infinitely many solutions answer. So we just got to see now, the question will be, are we going to be able to eliminate and cancel out these numbers? As I multiply -2 times 8, that's -16, and that does cancel out with 16. So since everything cancels out, we'd end up with getting 0 on each side of the equal sign, which would be a true statement. And so that's always true, so that means it's an infinitely many solutions answer. If you had the x's and the y's canceled out here, but these did not cancel out, you would get 0 equals some other number, which would not be true, and then that would be a no solution answer. So if you cancel all your variables out, you do have one of those 2 situations. It just has to be, everything needs to be canceled out for infinitely many. These would not get canceled out for no solution, though, because then it would make us an equation down here or some statement that would not be true. All right, going over to number 6, I'm going to have you try this one as well. First, you can go ahead and number your equations, and I'm going to have you eliminate, put together equation 1 and 3 first. So 1 with 3, and we're going to have you eliminate the y first on that one. So eliminate y first with the 1 and 3. Maybe I should put that next to it. No, I don't need to put that next to it. We'll just go ahead and say, combine 1 and 3 together, these 2, and then combine 2 and 3, and you're going to eliminate y on both of these. So as you combine 1 and 3, combine 2 and 3, eliminate the y. So 1 with 3. I'll show you what you should multiply by as well, even. You're going to multiply equation 1 by 2 as you're combining here. That way you're going to get, if you're eliminating the y, you'll get 4y and -4y there. And then when you do 2 and 3, you're also going to multiply the second equation by 2. You'll have the same situation here as well, 4y and -4y. So, and then once you're done with that, I'm going to try to see if you can get through this entire thing here. Once you're done with that, then go ahead and eliminate the x out of your 2 new equations. So you'll have a 2 by 2 system, eliminate the x, solve for z first. Find z first, then go ahead and then find the x number, and then finally find the y number. Alright, so go ahead and pause the video and see how far you can get on this and do your very best. Okay, so hopefully you have completed this. Hopefully you have an order triple as an answer. That would be awesome, especially if you got the right order triple answer. Wouldn't that be great? So as you go ahead and put together 1 and 3, here's what you should have got. As you multiplied equation 1 by a 2 here, you're canceling out the 4y's. You get a 2x now from that. You'll get a 5x from this combined like terms. negative 11z, and a negative 13 on the other side. So that would be your first new equation. And then you got to put together the 2 and the 3. Multiplying equation 2 by 2 would give you this. So again, you're canceling out the y's. And you put together all the like terms here, so you need 7x negative 7z equals 7. That's your second new equation. And now these two new equations, you want to do a 2 by 2 system. I wanted you to eliminate the x first. So as you see, the x's have a 5x and a 7x. So we can multiply 5 times 7 and get 35. Multiply one of them by a negative. It didn't matter which one you chose. I chose to do the 7 here, multiplying this one by negative 7 and this one by positive 5. So this will give me that negative 35x on this one, positive 35x on the second one. Again, multiply every term. It's like a distributive property. Increase every term by multiplying by negative 7 here and negative 5 on this one. So we got 35 all the way through this now on the bottom one. Combine these two like terms and we would now be able to solve for the z. We get 42z is equal to a 126 divided by 42. That is 3. 126 divided by 42 equals 3. So z equals 3. Then we want to go ahead and find the x next. So we're going to plug 3 back into one of these two equations here. And so I'm choosing to do it on the one with the 7s, all these 7s here. So we're going to just plug x here, or sorry, z. Plugging z in for 3. That's a 21z now. 7x minus 21. Add 21 to both sides. That's going to give us 28. And then divide by 7, which is 4. So x is 4. So hopefully if you got this so far, good. That would be great. And then we just got to take these two, 3 and 4, go back to one of your original equations. And again, you could have chosen a different one than I did and still get it right. In this one I chose, I think I chose the first one, yeah, the negative 12 at the end. So I did choose equation number 1. And so I'm plugging 2 in here for x. And let's see, no. What did I do here? Perhaps I did this incorrectly. Hold on. No, it's correct. I didn't do it incorrectly. I just looking at the 2 here, thinking I did plugging 2 in for x. No, not this time. X is 4. We found it down here. So x is 4. So x, replace the x with a 4. Then we have our 2y. Replace the z with the 3 that we found down here, right? So negative 5z makes negative 15 equals the negative 12. Combine like terms with 4 and negative 15, giving us negative 11. So now we have this equation here, add 11 to both sides, 2y, so now divide by 2. We're going to end up with a negative 12 plus 11, that's a negative 1. We're going to divide by 2 and get a negative 1/2. So y is negative 1/2. Our answer for this one would be 4 for x, negative 1/2 for z, and 4 for x, negative 1/2 for y, 3 for the z. Remember, it's x, y, z for the order triple. All right, let's move on to our next problem. But before we do that, let's go ahead and look at our joke of the day. So what did the mouse say to the other mouse when he tried to steal his cheese? You guys have heard this one. He said, "That's not your cheese." Okay, so like 2 by 2 systems or 3 by 3 systems also have word problems that we would want to write a 3 by 3 system to help us solve it. So that means there's 3 things here. If you're reading through this one on number 7, you see you found $6.60 on the ground, all in nickels, dimes, and quarters. So there's 3 things right there. Nickels, dimes, quarters, 3 variables, N, D, and Q. You can use those as your variables. It says you have twice as many quarters as dimes and 42 coins in all. How many of each type of coin do you have? So that tells you right there exactly what your variables are. The coins, how many of each coin do you have? So your last sentence, usually the question of the whole word problem, is going to tell you what the variables are, telling you what you want to find. We want to find nickels, dimes, and quarters. How many of each type? Well, in the word problem, there's going to be pretty much 3 statements to make 3 equations with. So if you were noticing, the second sentence says you have twice as many quarters as dimes. Right there, twice as many quarters as dimes. That means there's more quarters than there are dimes. So the number of quarters is going to equal 2 times the number of dimes that you have. So that's where an equation can be. 1Q is going to equal 2D. So, if you have, twice as many quarters as dimes. So that's how we want to do that. If we say we had, let's say, 5 dimes, for instance, twice as many dimes, 2 times 5 would be 10 quarters then. So that's why it's got to be Q. There's more Qs than there are dimes. So I know sometimes it makes it look like it's the wrong way, the other way around, but it really isn't. You got to think of it, well, if I have 5 dimes, that means I'd have 10 quarters. There's 10's more than 5, more quarters than dimes in this one. So that's one equation. Another equation you can see would be, it said 42 coins in all. That's how many coins you found. So the 42 coins in all, that means number of nickels plus the number of dimes plus the number of quarters would equal 42. So you can just write an equation like that. N plus D plus Q equals 42. And the last equation can be coming from this sentence right at the very beginning. It says you found $6.60. And we know how much a nickel is and a dime is and a quarter's worth. So we can just go ahead and do that. We can say from the $6.60, now the money as far as this is involved. And if we think of it in terms of pennies, that way we don't have to worry about this decimal. We can just make it 660 pennies. How many pennies is a nickel? That's 5, so 5N. How many pennies is a dime? That's 10 pennies, so it's 10D. And quarters are 25 cents, or 25 pennies, so 25Q, and it's going to equal 660. So just think about it in terms of that, where each of these is the number, the value that the nickels, the dimes, and the quarters are. Now you have your 3 equations. That's really the hard part, is getting it to where you can solve it. So now that we have our 3 equations, we want to solve this. We can do this by the elimination with these first 2. I notice I have a Q and a D. So what would be best is eliminate the N's out of here. That way I just have Q and D as well with 2 more equations. So in order to eliminate the N's, I need to make this into a negative 5N. So I need to multiply this second equation here by negative 5. And when I do that, I'm going to get a negative 5N, negative 5D, negative 5Q is equal to negative 210. That's the negative 5 times 42. And you notice we're going to cross out the N's. That way we can just have another equation here, a new equation, with just D and Q, like this first equation is. And so now it's going to combine like terms, so it's going to give me 5D plus 20Q equals 450 when I do 660 minus 210. So now taking these 2 equations, the one that says Q equals 2D, I can use a substitution method because Q is equal to 2D. So I can replace the Q in this equation with 2D. So that's what I'll do over here. So the 5D from our new equation down here plus 20 times Q, we're going to replace Q with 2D, is equal to the 450. So that's 40D right there. And then combine like terms, that makes 45D. And so then divide by 45, and we know 450 divided by 45 would be 10. So there are 10 dimes. So like we said before, when we said 5, dimes, well, there are 10 dimes really. So 2 times 10 would give us 20 quarters. So we can know there's got to be 20 quarters just by doing a little quick substitution mentally with 2 times 10 there. And then to find the nickels, we can go back maybe into the second equation, the one that says N plus D plus Q equals 42. Plug in the 10 and the 20 for those 2 that we found. So we'll get an N plus 10 plus 20 equals 42. So that's 30 right there. So subtract 30, and N is 42 minus 30, which is 12. So there's 12 nickels. So there's your answer. There's 10 dimes, 20 quarters, and 12 nickels. Alright, for problem 8, it just says here, find the values of A, B, and C. A, B, and C are these numbers here on the other side of the equal signs, so that the linear system has a ordered triple solution as this solution here, 3, negative 2, and 1, as its only solution. So that means your X, your Y, and your Z are these numbers. So what we can do is just take one equation at a time, substitute these numbers in, and solve for the letter that we're looking for. So for our first equation with finding the A, we'll substitute in 3 for X, so it's 3 times 3, negative 2 for Y, so it'll be 2 times negative 2, and the 1 for Z, so 7 times 1. and it's equaling a. So we're going to solve for a here. So just got to just a little bit of order of operations, and that's it. So 9 minus 4 minus 7, and when we just combine those together, you can do 9 minus 4 is 5. Now 5 minus 7, the a number is -2. So I'm going to give you a chance here. Go ahead and try to find b now. Go ahead and pause the video. Do the same thing for these two. Just next to it over here, find b and then find c. Okay, hopefully you found b and c. So letter b, as you plug that in, you're going to end up with a 3 here, and then 3 times -2, then a 1, and that's going to become 3 minus 6 plus 1, and that's -3 plus 1, so b is -2. Hopefully you got that as an answer. And then you found c by plugging those numbers in again for x, y, and z to find c. So 4 times 3, -2 times -2, and that's going to be 12 plus 4, which that will be 16 minus 1, and that's just going to give us 15 for c. So that one wasn't a hard one. That was just kind of more plug in the variables here, or these numbers in for the variables, and solve for the other letter. Okay, so problem number 9 on your extra practice says, does the system of linear equations have more than one solution? Justify your answer. So first of all, we're noticing these equations have fractions in them, which we are never a fan of. But always what we want to do when we see fractions in any equation, we would just want to get rid of those fractions by multiplying the entire equation by the least common denominator. So out of these fractions, or out of these numbers, I should say, from equation 1, you can see 2, 8, and 4. The common denominator would be 8. That would be our common denominator, because 4 can go into 8 and 2 can go into 8, and of course 8 goes into 8. So we'd multiply this entire equation by 8 to get rid of those. We would do, now this one we could multiply by 4, but again, we want to be able to be strategic. We're trying to solve a system. So since I multiplied this one by 8, notice I'm going to get a half times an 8, which is 4. And this one also has a half here in front for x. So I could multiply this by 8, which is still a common denominator, which would still eliminate all the fractions, but it would also give me a number here where I can do some elimination. Remember, we want to do that triple elimination. So I would do that, I'd multiply the next one by 8. So if I'm getting these two to become 4, then this one should be multiplied by 4 here to get a -4. So we want to multiply this bottom one by 4. So let's go ahead and multiply each one of these. So our equation 1 is we multiply through 8. Half of 8 is 4x, so we know it's going to start off with 4x. And then as far as the 8 here goes, we can cross out the 8 with the 8th on the outside, and it just leaves you with that -3y. And for the z, you can cross out the 8, just leaves you with a positive 1z. For the 4 on the other side, we're going to cross that out, but but 4 goes into 8 2 times, leaves you with 2 still to multiply the 5 by. So -5 times 2 would give you a -10 on the other side of the equal sign. And now for the next one, we know that we're going to start off with 4x again. Half of 8 again is 4x on the first one. We'll cross out the 4, but again, we'll multiply the numerator still by a 2. 1 times 2 will be 2y for the next one. Do the same thing for crossing out 4. We still got to multiply the 3 by a 2, and that's going to give us 6z. And then 0 times 8 is still 0. And then for multiplying by 4 on this last one, we're going to just see we have -4x. 4 times 2, positive 8y. 4 times -5z is -20z. And then 17 times 4, that would be our 68. So there's our new equations now, all adjusted to where we could eliminate the x's. So we're going to now just combine them together. Let's go ahead and combine equations 1 and 3. I'm going to use 3 twice because that's the one that's opposite these other two signs. So we'll do 1 and 3, then we'll do 2 and 3. So when I quickly do 1 and 3, I can just go ahead and notice I'm going to cross out the x's, just combine the y numbers together. So -3 plus 8, that's going to be 5y, and then the z's, take 1z away from 20, that's -19z, and then take 10 away from 68, or 68, that's going to be 58. So that gives us a new equation for 1 and 3. So there's our new equation. Now to do 2 and 3, again, we'll cross out the x's. We'll get 10y, take 6 away here, that's a -14z, and then we'll get just the 68. So we can just write that down for doing 2 and 3. 10y minus 14z, equals 68. So now again we have a 2 by 2 system. And don't forget what we're trying to figure out here. Does the system have more than one solution? So basically the only way it will have more than one solution is if it's an infinitely many solutions answer. It does want us to justify our answer. So really justifying the answer should probably be solving the entire thing and getting to the point where we can show that it either has infinitely many solutions, or it has no solution, or it has one ordered triple solution. So at this point we want to get rid of one of these letters. It would be easier to get rid of y than to get rid of z. So let's go ahead and multiply this 1 and 3 equation here by -2. So if I multiply by -2, it's going to give me a -10y, and then multiply by -2, it's 38z. Multiply here by -2, that'll be -116. So we're going to cancel out. I'm going to put that, just write it down below here. So multiply this first equation by -2, and then just rewrite it below this 2 and 3 equation. So we can cross out the y's, and then subtract 14 minus 38, and also subtract 68 and want the -116. So that gives us a 24z equals to -48. Now, what we've noticed so far is that we're not crossing out our letters. We're not canceling out these y's and z's. That's usually what happens when we have an infinitely many solution answer. So we're able to solve for a variable here. Divide by 24, we're able to solve for z and get z equals 2. So to really verify this, that it only has one solution, it doesn't have infinitely many, we can just keep going and substitute -2 back into probably this first equation here. So 5y equals -19 times -2. Substitute that z in here. That's going to give you a positive 38 there. So we'll subtract 38 from both sides. 58 minus 38 is 20, and then 5y equals 20. Divide by 5, so 20 equals 4. Or I should say y equals 4. Sorry, 20 divided by 5 equals 4. So now that we know these two, we can plug it back into one of our original equations. I would go with one of these guys, not with one of the fraction ones. You could go with this original one here. That would be okay. Let's see, which one did I choose? Looks like I did choose this one right here. This original one is what I chose, where we have a negative x. So that's the one we're trying to find as x. 2 times y is 4, so that's why that's 8 now. -5 times -2, that's going to give us a positive 10. And it's equal to the 17 that the equation shows. And then this will be 18 here. And so -x plus 18, subtract the 18 from both sides. That's -x equals -1. So positive x will equal positive 1. So our ordered triple answer is 1, 4, -2 for x, y, and z. So the answer to this question would actually just be the answer no. No, this doesn't have more than one solution. It only has one solution. And this is the ordered triple solution. Alright, we have one more problem to do, and then we'll be done with this lesson. Okay, so problem 10 is actually a little bit of a geometry problem, but using systems of equations to help us solve it. It says that if angle A is 3 times as large as angle B, and angle B is 30 degrees smaller than angle C, what are the measures of angles A, B, and C? So there's right there your variables. We're trying to find A, B, and C. When we write in our equations, we'll use A, B, and C as the variables. And then as far as the equations go, you can see, as we saw before, part of the sentences is going to make the equation. So we have one coming from right here, that angle A is 3 times as large as B. A second one coming from right here, that B is 30 degrees smaller than C. But where's the third one? That would be the question. I don't see another sentence anywhere to write a third equation. Well, there is a third equation. It just happens to be that angle A, in a triangle, all three angles of these interior angles here all add up to equal 180 degrees. Now, you should have learned that a while ago at some point, but you may have forgotten that. You may not know that or remember that. And so you would have had to know that to really do this problem. So we're just gonna write that down for our first equation here, that all three of these, A plus B plus C, is going to equal 180 degrees. So I'll just put 180. So they all add up to 180. And then we can do the A is 3 times as large as B. So measure of A is 3 times what B is. So A equals 3B. And then it says here B is 30 smaller than C. So we can put down that B equals C minus 30. That's another thing we can do. So now at this point we would want to try to solve the system. There's our three equations. We would want to solve this, and one way we can do that is we already know what A equals. A equals 3B right there. So we could substitute 3B in for A, and now I have two B variables in here and one C variable. So it would be nice if we could substitute something in for C that would just have a B in it. So I could take this equation and solve it for C by easily just adding 30. So when I add 30 to both sides, C is by itself, and C equals B plus 30. So there's what I could substitute in. I could take that 3B, substitute it for A, and take the B plus 30 and substitute it for C. So let's do this on the other side over here. So instead of A, I'm going to write that it's 3B. Then the next one is the B, plus the B from the equation here. And then plus C, but instead of C, we're going to write B plus 30. And then we'll finish it off with it equals 180. So now we have an equation with everything with the letter B. So we just combine the like terms with the B's here. 3 plus 1 is 5B plus 30. Subtract 30 from both sides. That gives us 5B equals 150. And then divide by 5. 150 divided by 5 is 30. So B is 30 degrees. And now we can go ahead and just plug that back into right over here where A is. A equals 3 times 30. So that's what A will be. 3 times 30 is 90 degrees. A is a 90-degree angle. And we can take the 30 degrees and plug it back here for C equals 30 plus 30. And so that would just be 60 degrees. So C equals 60. So you can write your angles in the triangle that A is 90, B is 30, and C is 60. Alright, so that finally concludes our lesson on the triple elimination of this 3x3 system. And you want to go on to your assignment for this lesson, and I will see you on the next video.